Hi, so let's suppose it's test day, the MCAT, and you're breezing through the chemical and physical foundations of biological system section at a rate of about 1 minute and 30 seconds per question. But then you stumble upon a calculation like this. You have something like 0.55 grams. So right away you can probably tell that this is the amount of a substance that you have or that's given in the question. And then let's say it has a molar mass of about 204.2 grams per mole. My question to you is, can you tell me how many moles are present in the substance? So don't panic. Because you're not allowed to use a calculator, that's fine. These calculations are pretty straightforward. They just require a little bit more attention. And so the only thing that you need to do is implement a little bit of your algebraic skills. And the first thing that you're going to notice is that you have to perform some long division. But we know that when we have decimals, we have to change them into whole numbers in order to effectively perform long division. So in the numerator, you're going to multiply by 100, and in the denominator, you would need to multiply by 10, but this 100 overrides the 10, and of course we know that whatever you do to the numerator, plus it's a whole number, and multiplying the denominator by 100 will change it into 20,420 grams per mole, okay? So that's what we're going to do. And I'm going to indicate the new location of the decimal points. There's an empty space right here that has to get filled with a 0. So our new dividend now becomes 55, and our divisor is now 20,420. Okay? All right. So my first question to you is, how many times can 20,420 go into 55? And obviously the answer is 0. All right, so I'll implement the 0 there as a placeholder and also a decimal place, because we know that we have to continue onward with our solution. All right, so I put a decimal place in the quotient and also 1 in the dividend. Now, how many times I'm going to implement an imaginary 0 in the dividend so that I can figure out the answer to this. So, ignoring the decimal place here in the dividend, how much times does 20,420 go into 550? Of course, 0 times again. Let's implement another imaginary 0. Ignoring the decimal place in the dividend, how many times does 20,420 go into 5,500? Again, 0 times. Let's implement another 0 to see if we'll get somewhere. Ignoring the decimal place, how much times would 20,420 go into 55,000? All right, let's see. Well, 20,000 times 3 gives us 60,000, so it can't be 3. It has to be 2 times, and that should work. So 2 times 0 is 0. 2 times 2 is 4. 2 times 4 is 8. 2 times 0 is 0. And 2 times 2 is 4. All right, so let's subtract and see what our remainder amounts to. 0 times minus 0 is 0. Well, you can't subtract a 4 from a 0, so we're going to have to borrow from this 50, creating a 49. All right, making this a 10. So 0 became 10, and 10 minus 4 is going to be 6. 9 rather than 0 minus 8 is 1. And 4 rather than 5 minus 0 is 4. and 5 minus 4 is 1. Alrighty, that was some trick we just went on. Alright, so now we are going to implement another imaginary zero because that's just the sequence of it in long division. Bring down that 0. How many times would 20,420 go into 141,600? Okay, sorry, had a little brain fart there. And so we know that 20,000 goes into, let's say 140,000, roughly 7 times. But since this is a little bit more than 20,000, I'm going to guesstimate down 1 unit to 6 times. And let's see what we get. So 6 times 0 is going to give us 0. 6 times 2 is going to give us 12. Write the 2, carry the 1. 6 times 4 is going to give us 24. Plus this 1, 25. Write the 5, carry over the 2. 6 times 0 is 0. Plus 2 is going to give us 2. And 6 times 2 is going to give us 12. Alright, so let's try to figure this out. Although I don't think I'm going to continue any further with the problem, let's just fold the answer over here, the remainder. 0 minus 0 is 0. 0 minus 2 can't be done. Borrow from the 6, creating a 5. 10 minus 2 is going to give us 8. 5 minus 5 is 0. And 1 minus 2 can't be done. Borrow from the 4, creating a 3. 11 minus 2 is 9. 3 minus 2 is going to give us 1. Alright, so, and then 1 minus 1 is 0. The remainder is, it's really tiny, 19,080. Not going to go any further, so this should be sufficient. So our answer would be 0.0026. But what about the units? So let's analyze the units using dimensional analysis. So we have grams in the numerator divided by grams per mole in the denominator. So we know that division by a fraction is really the same thing as saying multiply by the inverse of that fraction. So we're going to get grams times moles per gram. The grams cancel out, and our final unit solution is moles. So the final answer to this problem, I'm going to write it up here, is 0.0026 moles. Okay? Or if you want to be more precise, or if the answer choices are in scientific notation, you're going to have to shift the decimal place 1, 2, 3 times. So 2.6 times 10, we had a 3-place shift, so indicate that in the exponent. But since we're shifting to the right, it's going to be -3. And this is our final answer.